Hello, everyone. This is a workshop at the International Conference of the System Dynamics Society in July 2021 in virtual Chicago. It's about sensitivity analysis, optimization, and user-defined functions with PowerSim Studio. I'm Len Malchinsky. Jake Jacobson and I own Mind's Eye Computing. We're authorized resellers of PowerSim Studio in North America. This workshop can't be a complete instruction in these three topics, more of an introduction, and hopefully show you places that you can go to learn more and do more. Okay, in PowerSim Studio, there are basically some possible ways of running simulations. You can run them without uncertainty and with uncertainty. You can run them without optimization and with optimization. So let's look at these quadrants. The first is basically what most of us do. Every scenario or what-if analysis has to be run by us or our clients manually. So you'd like to change the value of a constant, you move a slider, you rerun the model. You could run that model with uncertainty using Studio's risk assessment capabilities. So the tool will run through the model many times to find the results with the uncertainty assumptions that you've given it. You can also run a model without uncertainty and with optimization. So the model will run in what are called generations to find the value of some decision variable or variables that will give you a result that's closest to the objective that you set. So much like a linear programming approach where you say, I'd like to minimize something, here you might say, I'd like to maximize my profit in this small supply chain model. What are my decision variables? Run the model many times and tell me what to set those decision variables at in order to maximize profit. And then finally, running models with both sensitivity or uncertainty and optimization. It'll run several times, but it will put uncertainty assumptions or distributions on some of your variables. We'll take a look at some of these things. The first one is risk assessment. Hopefully down at the bottom of the screen, it may be cut off in the video, but you'll have access to the slides. You can see some links to sensitivity analysis video and some information on the PowerSim website. So we want to identify how sensitive the model is to changes in assumptions. And assumptions are often related to uncertainty. Obviously about the future, right? It's difficult to make predictions, especially about the future. You might have some issues about the cause and effect relationships between elements of the system you're modeling, and you'd like to look at the sensitivity of those. Your assumptions can be defined as fixed values or probability distributions. So you might say, I believe this value is X. Or you might say, I believe this value has a mean of X and a standard deviation of Y. And then that allows you to run the model multiple times, possibly thousands of times, and see what happens. Effect variables are those variables that you'd like to see the outcome for. You want to see what is the effect of uncertainty on these selected effects variables. Okay, here's a stylized flowchart of how you might do this. You have a starting point where you look at what Studio calls decisions and then assumptions, and you simulate the model with those varying assumptions. You get the effects as a result, and then you can look at how those effects are distributed, and then you're finished. So it uses sophisticated sampling methods to produce the sampling values, and they're defined by probability distributions before the model starts running. Studio has two sampling techniques. One is Latin hypercube, and the other is Monte Carlo. And I guess the major difference is Latin hypercube is quite a bit more efficient than a Monte Carlo approach. Latin hypercube, I believe, takes account of the variation in some of your assumptions, whereas Monte Carlo runs through all possible combinations, and that can take quite a long time. Okay. Risk assessment. Excuse me. Risk assessment can produce a graph like this. In a second here, I'll show you what it means. It produces distributions of values. The probabilities of the results can be studied in different ranges and below and above certain percentiles. And then finally, it identifies the likelihood of undesirable as well as favorable results. I'm going to get my pointer turned on here. And let's just take a look at one of these outputs. I don't know specifically what settings were, but I do know that this red line is the expected or average value over time, right? And these different colored stripes are bounded by probability values. 95th percentile, probably. This one might be 75th. I'm not sure what this is. That's obviously the 50th. Maybe this is the 95, 75. I'm not sure. But now you have a range. So when you're dealing with clients or working on your own, you can see from the start of time of this particular simulation, over time, this value, whatever it might have been in US dollars, has this range. And you can reply with a probability as to whether, for example, the profit will exceed this amount, which seems to be about $3,500,000. So it looks like there's a 50% probability it will be above that, and a 50% probability that it might be below that. Okay? So risk assessment is set up in the tool as what's called a risk assessment clone. All right. The decisions, the assumptions, and the effects are added by clicking on any one of them, and then a list of possible model variables will appear in a list. So let me do a little animation here. So there I've set up a risk analysis clone under my main model, my main simulation. Once I've done that and clicked on analysis variables, which is right here. Oops, my mouse is misbehaving today. It certainly is. I don't know why. All right, it's right here. Assumptions, decisions, objectives, and effects will appear. And we're only concerned about assumptions, decisions, and effects. And then if we click on one of these, this will give us the variables that are available in the assumptions subset, for example. And there they are. Okay? How will we define decisions? Right? we'll double click on that chosen decision, that decision variable, to define it. We can say when we would like to apply that decision, what its minimum and maximum value are. An actual value is the value at that point in time in the sense of your modeling. If you had set the original variable, in this case at 2.2 days, that's what it would show. Okay. You can also clone decisions and have multiples of the same decision. Okay. Now, when we're talking about assumptions, we can pick a variable and say, all right, let's apply that at start time. Let's use a truncated normal distribution. And those of you who are paying attention, this is a European version of PowerSim Studio. So instead of using a period to indicate decimals, keep losing my pointer right here, I'm using a comma. So that's a 77.5% per day, the standard deviation of 0.75% per day. Here's a lower limit and an upper limit using this truncated normal distribution. And you can see the distributions that are available here. Go forward. Okay, so we're going to look at a risk assessment model of an inventory with regards to the uncertainty of various assumptions. We'll set up and define assumptions and effects. And in the supplementary materials for this workshop, you should find available this file, e-ra01 riskassessment.zip. So I'm going to pause our video and then load the PowerSim Studio model, and I'll be right back. Okay, I've opened the model, and let me make sure you can see here that I've created this risk analysis clone. How would I do that? I go up here to my inventory management, right click and say add risk analysis, which implies that you can have many different risk analyses attached to the same model. I'm not going to do that right now. All right. When I have my risk analysis, I can look at my analysis variables. And because of PowerSim Studio's ability to have multiple windows open simultaneously, I've got the analysis variables from the risk analysis 1 clone right here. Here's the assumptions. Let's take a look at inventory cost factor. I've got this set up as a uniform distribution. I can double click here and open that up. Sorry, it's so tiny. All right, I'm applying it at the start. I've got a minimum and a maximum value. This is a uniform, so any value between 5 and 10% per day is equally likely of getting chosen. Right? That's an assumption. My decision variable, inventory coverage, applying that at the start. Here's a minimum of 2, a maximum of 3, and an actual of 2.62. And then the effects. For total profit, I'll open this up. These are the results I would like to see. The average, the 10th, 25th, 75th, and 90th percentile. And the model is run many times. Right? I didn't see where I chose my Monte Carlo. Oh, here it is. On assumptions, I've chosen Latin hypercube with a run count of 40. So it will do 40 samples across the variation in those variables. And I'm just going to rerun this. It's a little hard to see. It just finished running the model 40 times. And you can see this is not a very, very large model. I can go to File, Project Information, Statistics, and note that there are only 18 variables here. I have no arrays or subscripts, so it's not that complicated. And what I'm trying to do is look at the change in total profit. All right. If I go back here to shared diagrams, which is my main model, not my risk analysis clone, and run it again, you can see what's going on here with my inventory. Part of the reason for this is there's a delay here in supplies arriving, and there's a delay here in knowing what my expected demand is, and I've also got some randomness in my demand. Let's open that up. What am I using here? I'm using a couple of sine waves and a Poisson distribution to alter that demand. In fact, just to show you what's going on, let's see here. Let me go back to the model. Let me put a graph on this demand over time. Got the graph, throw the demand onto it, and then I'm going to move that onto my control panel and put it here. All right. So because of that randomness in the Poisson distribution and the two sine functions I've thrown in, that's what demand looks like. And then again, this is my sensitivity analysis of the profit. This model is available. You can always go back and delete each of these and then try something on your own. So what I'm going to do is I am going to get rid of total profit here. And delete total profit, okay? And the effect I'm going to add by right-clicking, add effect, gives me a choice of the effects. I'm going to add inventory. Open that up and say, what would I like to see about inventory? Right-click, get its properties, and I'm going to throw on take average off and just do a 50th percentile, a 10th, and let's say a 95th. I'm take standard deviation off. And I'll throw high and low. Apply, OK, and run it. It's running through those 40 simulations. And of course, I don't see anything here because I deleted those variables. So I'll grab the properties for this one, double click on the edge if I can, and say what parameters would I like to see from my analysis clone. Go to my effects, go to inventory. At the top, I'd like to have high, then 95th, 50th, 10th, and low. Apply, and that's what I get. Let's run it again. "40 times. You look at the graph and you don't see any colors. Wonder what's going on. Well, those assumptions and those decision variables don't seem to have an impact on inventory. They do on profit, but not on inventory. All 5 of those lines are literally on top of each other. So that shows me that inventory is not sensitive to those variables. Okay? Let's see if I've got inventory plotted right here. And let's see if I can change this not to a fill. Oh, let's let's see, do I want to have a fill? I'm going to say white here, apply. I mean, it is true that all of this is inventory, but I just took that off to show that it's this. Okay? I'm going to close this, not save it, because I want to keep the original version. I know, and let's go back to PowerPoint. Okay, so there we have risk assessment. Let's try to move forward. All right, here was the defining of effects. Here's the simulation. And now we move to optimization. And again, at the bottom of your screen, you'll see a web page. Let me get my pointer back. A web page here where there's more information on optimization, and then a YouTube video, which is probably a PowerSim Studio webinar on optimization. So you can optimize your simulation with regards to a set of parameters known as decisions. A decision is a changeable variable controlled by the person who's managing the modeled system. We might call these policy levers. The assumptions can be added, again, as fixed values, right? My mouse is misbehaving again. They might be associated with uncertainty. And you have to provide an objective, a criteria for determining the target behavior. And you have a choice of some operators. Let me go again to the next slide. And here's that rough flowchart. I have a start. I'm picking decision variables. I'm simulating, given the assumptions. Darn it, I'm setting my objectives. Maybe I'll switch mice here. Yes. I'm setting my objectives and I get my results, and I can accept or repeat the cycle, right? Boy, even my touchpad is misbehaving. And then it will finish when it thinks it's found the best decision. So it uses what's called an evolutionary search algorithm that was developed by this fellow, Nicholas Hansen, and it was licensed to PowerSim AS in Norway to be included into the PowerSim tool. Okay, and the process is repeated, of course. It has algorithms that say if after X number of runs, I don't get any closer to the objective, I will just stop the optimization process. Back to slide. Again, it's also set up in the analysis variable window. Decisions. You pick another analysis variables. Decisions, objectives, and assumptions are there. And then again, depending on what you pick, possible model of variables will appear in a list. Okay? So, you can double click the chosen decision to define it. You can choose the apply time, the minimum, the maximum, and you can also clone those decisions as you could clone earlier. You'll choose the assumption to define it. Is it a fixed value? Does it have a distribution type, etc., just like we did. And then this is different. What are the objectives? Click the chosen objective. Inventory, in this case, we're applying it at stop time. If you have multiple objectives, you can actually put weights on them. I believe if the weights should either sum to 1 or the weights will be weighted themselves. And this is just a normalizer here of one widget because inventory is measured in widgets in this example. And then here what I'm trying to do is maximize widgets. Okay. Let's go forward. I'm going to press the optimize icon, which looks like this. Decide on the number of runs, and this is quite sometimes difficult to decide. I usually stick with the default value. So typically it starts with 300 generations of 3 parents, each having 15 offspring. And this is part of Dr. Hansen's approach, this evolutionary search algorithm. The 3 best parents are used to define 15 new offspring to run the next generation, and that process is repeated 300 times. Okay, the seed is just a positive number to initialize the random number generator, and you can revisit and change assumptions as you like. Go forward. When optimization is running, you can see the values, the actual value for the decisions and the actual value for the objective. So again, I'm going to pause the slides, and you should open Studio and the E-optimization and risk model. So I will do the same. Okay, I'm back. Here's that same model that we saw before when we applied sensitivity analysis. But notice now that my decision variable is inventory coverage, and my objective here is total profit. Let's open the objective window. It's only relevant when working with risk analysis. All right, my objective is total profit. Here it is. At stop time, I'd like it to be maximized. So what's it going to try to do? Where is inventory coverage? Inventory coverage, where is that value? Ah, here it is, right here. Notice that that's a constant. What do we mean by inventory coverage? Typically, it's the number of days based on the current sales rate of inventory that I'd like to have. So let's assume you're selling textbooks. And you have John Sterman's Business Dynamics. You happen to be down the street at the MIT bookstore. How many days worth of those books, given current sales rates, would you like to have on the shelf? And given the other variables and behaviors in this model, excuse me, what's the best inventory coverage with the criteria, the objective of maximizing profit? Now, I don't think this is John's book because, oh, maybe it is. They're doing quite a good sales, $3 million worth over the runtime of this model, which is 3 years. Excuse me, I've got a bit of a cold and coughing quite a bit. So it's all set up. I can run the model as is, and I get some things like that. Okay, let me look at my inventory coverage. I'll reset the model. My inventory coverage, to open that up. Just set to 1 day. Gosh, I'm going to change that to 4 days without changing any of my optimization setup. Okay, now I'll go to optimization setup. I've got my minimum, my maximum, and my actual. Here is 4 days. Apply. Oh, sorry, it's got to be less than or equal to the maximum. It's got to be 3 days. Let me go back here. Change that to 3 days. Sorry, interrupted by phone call. There we go. Oh my gosh, another phone call. Let me hit pause. Okay, I'm back. So, I'm going to hit the optimize button here. And up comes my optimization window with the defaults of 300, 3, and 15. If you click here about solver, this tells you about Dr. Hansen. I'll just go to next. And it's showing me all the same thing that I've set up here on my own. Next again. There's my operator maximum. I hit finish. And there it goes. I should probably be playing some music in the background here. Let's see, it's at almost 400 simulations, 500 simulations, surpassing 700, 800, 900, 1,000, 1,100 now, 1,200 simulations have been run. Don't forget, it will stop short of 300 generations if, based on the algorithm, it can't do any better in maximizing the profit. Almost up, let's see, almost to 2,000 simulations, and it stopped. Okay. It's finished with stagnation, so it can't improve. I will say okay. And it's got a profit here of $3,613,331.05. And the optimum inventory coverage should be 2.62 days. Of course, given all the information, both the settings in the data and the behavior that's implied by the feedback in this model, including, don't forget, I've got a random demand variable here. I forgot what we had set that to. Oh, right, it's a Poisson with some sine wave perturbation. Okay? So if I go in here to inventory coverage now, it says 3. I could change that to 2.62 if I liked. All right. Let me minimize this, and let's go back to the slideshow. And continue. Let's now talk about user-defined functions. Studio has built in something like 200 functions. They're grouped into categories, of course, and they do all kinds of interesting things. There's also another video you can watch here about functions. Sometimes I call this, what do you do when you can't figure it out or would like to do some so-called extra methodological processing in an SD model, comma, or something else, etc. Okay, so there is built in this idea called VBFunction. You can use Microsoft internal VB script engine that comes with Windows to write your own functions. Or you can write your own DLLs, dynamic link libraries, using C++ routines. We're going to look at the first one. I can't go into C++ here. Things get quite complicated, but at Mind's Eye we have successfully done that, and we're looking more and more into that for sort of out of the ordinary kinds of functions. Okay, so VBFunction, again, it's got great power and great responsibility. If you embed a VBFunction command anywhere in your model, Studio will warn you whether or not you want to enable this active content. Because if you're evil or nefarious, access to VBScript allows you to do some very interesting things to the operating system. So your clients need to trust you. You need to place some trust in models you're getting. You might not want to run them immediately. You might want to check out what people have built into VBFunction. But if you use it, and I do, it enables the so-called classic procedural programming language constructs of sequential execution, iteration, and decision making. It accepts input from other model variables that are not in the VB function, and it runs every time step, which is quite interesting. You can find a lot of sources of procedural code. So I'll talk about a problem I had earlier where I went to texts to get code in, what did I use originally? C, and I converted that to VBScript. I've converted BASIC to VBScript. If you go to this long URL, I hope you can see it at least in the printed version. Microsoft has a VBScript tutorial that's free online. Okay, what have I done? Primarily data manipulation. I've done a lot of data manipulation. Search and sort algorithms, ordering of data, putting it in certain kinds of orders, binning, basically doing histogram-like calculations. I've also embedded operations research kinds of problems into VBFunction. Minimal spanning tree, so having a set of points and trying to find out shortest distance in a network. I've also used the latitude and longitude data types in Studio to help me determine the distance between 2 points on the Earth with a high degree of accuracy. That can also be done with simple trigonometric functions that are built into Studio, and you don't need VBFunction. Okay? But the important thing is this note at the bottom. It's always run speed appropriate. Try a Studio function first before trying VBFunction. And I have at least one strong memory of me trying to implement a triangular distribution in Studio with VBFunction when one of my colleagues walked in my office, looked over my shoulder, and said, "Why are you doing that?" And I'd say, "What do you mean?" He'd say, "Why are you doing a triangular function? It's built into Studio." I failed to look at the function list. So always do that first. Your model will run faster. Okay? So here's a VBFunction. I've got a range called cells that is 1.10. I've added that to global ranges. I create an array with the dimension of cells, and it's filled with random numbers from 1 to 100. That's all done in my model. Then I've created an auxiliary. So VBFunctions are only used in auxiliaries. Why? Because they're calculated at every time step. And there it is. This is the actual code. VBFunction, all of these quotation marks are required, right? All of these delimiters are required. Note at the bottom, if you're going to build VBFunction, save your model often. I've had students put looping, 4 next loops that ran infinitely. So once they started the model running, it would never stop. They'd have to crash the model and lose whatever changes they had recently made. I mean, Studio now has a save feature if the model run is uninterrupted, but you should be careful and build incrementally. So here I'm running for I equals 0 to the upper bound on my array minus 1. Why? Why? Because VB script, when it deals with arrays, orders the elements starting with the number 0. So instead of going 1 to 100, it will go 0 to 99. And that's why I have to take the upper bound, which is 100, and subtract 1 to get 99. But this is a traditional bubble sort. You can find this algorithm almost anywhere on the internet. So there's my dimension for my output. It's cells 1 through 10. There's my input. And there's the actual script. I've got a delimiter here to end the script, this parentheses, and a parentheses here to start the script. Okay. I added here the delimiters. All right. Gosh, that's the end of this. If you'd like more information from us, you can go to mindseyeComputing.com. There you'll find more than 90 free studio models that run in the free Studio Express. Nothing on optimization or sensitivity, because those features do not come with the free Studio Express. There's also an independent PowerSim Tools user group. Independent, we mean it's not run by the PowerSim company in Bergen, Norway. And then finally, if you're interested in a lot more detail about Studio, obviously go to the PowerSim website. And that's it. Thanks for listening. See you in Frankfurt next year. Bye.